All right, in theory, we're live. As always, we require someone to externally validate our existence, to let us know that we do indeed exist. So come on, tell me. Oh, there we go. Someone just said that we're live. So I can only assume that we exist. Phew. So what do people have planned for the holidays this year? Anyone? Brian?
Keeping warm.
You're gonna keep warm?
It's just gotten cold here and snowy, and yeah, I plan on having a good hefty pint and staying inside.
Yeah. Yeah, we're just gonna try and stay dry here. It doesn't get
Yeah,
that cold, it just gets so wet.
yep.
Oh. Have has anyone else watched The Expanse yet? We gobbled up all of season 4 in
Oh,
3 days. All gone.
not yet.
4 episodes. I'm
You're
four
four you're
episodes.
4 episodes in? Yeah. Yeah, it's
Yeah,
so
yeah.
good.
We're watching the next one after this. So
Yeah.
we can't do any streaming cheating with my spouse.
Yeah, some shows are just like completely off limits.
Yeah,
Yeah,
that's
no.
exactly it.
Yeah, absolutely. We have the same situation. But The Expanse is one. Rick and Morty. Like Carla got really ahead on like Peaky Blinders, and she's watched Vikings. But no, The Expanse, that's forbidden.
Yeah, The Expanse is forbidden.
Yeah, and I mean Carla's even more draconian about it. She wants them to just keep working forever. That they should not be allowed to take breaks. They should just keep making more shows. So.
Wow.
My wife went to, this isn't in book four. I gotta start reading book five.
I'm going to say hi to a bunch of people. Hi to Andy Cowley, Astro B, Bob Moeller, Christian Woodland, Dan Niles, Daniel McCool, David Dunn, David Fairweather, Ian Farquharon, Janelle Duncan, Johnny J, Larry Beckham, Nancy Graziano, Nifty, that's awesome, Paranor, Psycho Cat 749, Rich Wilson, Tom Van Scotter, Tony Flucha, and Zapfan Zapfan. Hey everybody. So, well, I guess we'll talk about Starliner in the actual show. And I don't know if you saw Snow Crash has been announced. They're gonna make that's gonna be on HBO Max, I think. From Neil Stevenson, which is like one of my favorite books. And they're doing the Culture series on Amazon, and they're doing the Foundation series on Amazon.
I
Yeah,
didn't hear about the culture series. Okay,
yeah,
I'm excited.
yeah, yeah.
Or horrified. I don't know
I
which
don't.
to
Yeah,
be.
I know it's a tough one, right?
Might be worth trying Amazon again. Wow.
Yeah, yeah. Actually, it's weird. Like pound for pound, actually, Amazon has the most TV and movies, especially like cool
Hmm.
documentaries, than any of them, even more than Netflix now. Maybe that's just in Canada, but it's kind of amazing how much content is actually available on Amazon now.
Maybe that changed because we just saw everything that was cool you had to pay for extra. So, yeah.
Yeah, no, no. But I mean, you can pay to get even more. Like you can watch like here in Canada, you can watch Rick and Morty through an extension to Amazon, but you do have to pay like an extra $10 a month to get TV shows.
Okay. Got it.
Yeah.
Yeah. We didn't
So
do that. We just tried the free trial.
yeah, but no, just like with your Prime membership, you get a ton
Yeah.
of stuff. So apparently Pamela is going to join us, but I will. That by we already have Pam, but another Pamela will be joining us. So we will go from there. Yeah, Horizon's Bravest Thing. I don't know. I found most of Amazon's library as pretty lame. Yeah, so go. There's a service that I use called Just Watch, and so if you go to Just Watch and then you just select Amazon Prime, and then you can filter it. So just show anything that gives, say, 80% Rotten Tomatoes and a 7 or higher on Internet Movie Database. It'll filter the whole library down to, but still, 500 or 700 movies, documentaries, stuff from different countries. It's kind of amazing. So, I Amazon, and again, maybe that's just a Canadian thing. I don't know whether you have less stuff in the U.S., but the amount of just like great, like we watched lots of translated stuff from other countries. It's great. A lot of documentaries. We're wildly entertained all the time by what we could find on all of them. Too much. In fact, I'm getting to the point now where I want to try the experiment of just cutting everything and just going one per month, just rotate. So this month we only get Disney Plus, and then the next month we only get Netflix. So, but then I don't have the guts, because then when like say, The Witcher comes out, I'm like, oh, I just want to watch The Witcher. So, which is like tomorrow, Friday, I think The Witcher comes out.
Yeah.
All right, Pamela, you're going to have to join us when we in mid-transit. So let's get started. All right. There's me. Here's my intro. All right. Hello and ow. My desk. Hello and welcome to the Weekly Space Hangout for Wednesday, December 18th, 2019. This might be the last episode, I forget, of the year. I'm Fraser Kane, publisher of Universe Today. This week we're going to be talking about solar eclipse, meteor shower, auroras on Mars, and whatever Pamela wants to talk about. We don't know. Joining me today, we've got Dr. Brian Koberlein. Brian, welcome back.
Hi. Thank you for having me again.
And we've got Pam Hoffman. Hi, Pam.
Hello.
And Pamela Gay is going to be showing up. So when she does show up, then we will continue the introduction with her. But before we get into the main guest this week, I want to give a big shout out, as always, to our good friends at the Weekly Space Hangout crew. These are our producers. These are our schedulers, and they are, of course, the great community that talks about the show and tells us what topics we want to talk about. And we really couldn't do the show without them. So if you want to join this amazing community, go to wshcrew.space. They'll give you access to all of the cool tools so that you too can be the executive producer of this show. And then you can be my boss, like everybody else is. All right. Joining us this week, we've got Anita Gale from the National Space Society. Anita, welcome to the Weekly Space Hangout.
Well, thank you very much. It's a pleasure being here.
So you are, we actually had your president on just a couple of months ago. But for people who don't know, who are you and what do you do?
So I'm a retired Boeing engineer. I worked on the space shuttle program from before it started flying until after it stopped flying. That puts me in a kind of vintage for a woman engineer, where when I was in college at the University of Washington, oh, by the way, go Dogs in the Las Vegas Bowl on Saturday. I'll be there. When I was in college, engineering enrollment of women passed 1%. So I was first woman, only woman, most vintage woman, and most everything I did in my career. And I retired from the Boeing Commercial Crew Program in 2016. Well, it was one of those things where I was doing everything on time. It was a fixed price contract. So, well, it happens in the aerospace industry. I got laid off because my reward for doing everything on time.
Right. You were done. And so then they need to wait for everybody else.
That's how much fun the aerospace industry is. Yeah. I'm still friends with my boss. It's okay. And in my copious free time, starting in 1984, I was asked by the National Explorers Conference, the engineering cluster, science and engineering cluster of National Exploring Conference. It's kind of like a Boy Scouts Jamboree, except it's for the Explorer Scout kids. I was asked to do a program on Thursday, cool all day, about space for their conference. And that ended up being a space settlement design competition where we had, at that point, 75 kids, and we gave them a challenge to design a space settlement. And over all of those decades, since 1984, we've been doing this a lot of years. This has now grown. Space settlement design competitions have grown into something that is global. We have semifinals all around the world. I travel to them. We have we will have 4 semifinals in the United States. We have a finalist competition at Kennedy Space Center. And we are a space contest. We also are an incredible STEM activity. We do steer kids into science and engineering and other STEM careers. And how we run the competition is we run it as an industry simulation. So we make the experience as close to being on an industry proposal team in the space business as possible.
So
kind of in a nutshell.
So then what is, like, you know, when the various, when the students come forward, and how do you define what the goals are that they're trying to accomplish? So what are their marching orders?
Okay, so we give them a program book, and there are two kinds of competitions. One they do in their school. We call that the qualifying competition. They have several months. But most students get involved through live competitions, a weekend. They'll come on a Friday. We talk to them about what's going to happen to them that weekend. We give them some, what we call technical training. We give them a program book with about 14 pages of what we call future history. We literally describe in a certain year, let's say it's 2059. And we'll say in 2059, there's solar power satellites, there are people living in space, there's commodities being produced on the moon. It's an ambitious future history, but we define that. We define subcontractors producing commodities and services. And then we give them a request for proposals. So this would be like an industry. You respond to a customer that puts out an RFP or request for proposal. I, for instance, worked on the RFPs for Commercial Crew. I worked on proposals answering the NASA RFP for Commercial Crew, cargo resupply services, space shuttle upgrades. So I basically have translated my experience in industry into an event for students.
Right. So you give them sort of the landscape of, these are the things that you can assume that you have at your disposal, that when you request a pile of raw metal, it will show up at some reasonable expense, that there are places that you can get your various volatiles, etc. So then, okay, so they've got this sort of environment, and then what are they required to design?
So the RFP is for designing either a space settlement or a space habitat. Now, when we say habitat, we'll define maybe 300 to 600 people. When we say space settlement, most of our scenarios are between 10 and 25,000 people.
Wow.
Every one of them. Yeah. Oh, yeah. This is where we're going O'Neill and bigger.
Yeah.
We've actually had a scenario where it was at initial operating capability, it was about 15,000 people, and they had to allow for expansion up to 80,000 people. So we really challenge them. They need to think about, we actually divide the RFPs, and we also give them an organization chart. So we have these students working in groups of about 50. We give them a real manager from industry to be their CEO. And then we have a KID president, 2 KID vice presidents, and 4 departments. So they're really learning how to work in an organization chart, which, interestingly enough, we're realizing is not taught in business school. Working in an organization chart means understanding what your department has to produce that other departments need and what you need to acquire from other departments. And business school teaches you how to operate in an organization at the tippy top, not in the bottom of 180,000 person companies.
Yeah.
That's what we teach. So the RFP is divided into requirements for what we call structural engineering, which is the overall design of the settlement, operations engineering, which is basically infrastructure, communication, agriculture, transportation, power, those sorts of things. Human engineering is incredibly important. That is not just spacesuits and safety, but also has to do with community design and housing design and diet, that sort of thing. And then for the kids who are only interested in computers and robots, we have what we call automation engineering.
And so then how are they judged? So they design a habitat for 15,000 people, maybe up to 80,000 people. You've got resources that are going to be available from space. What are they expected to come up with?
So the RFPs are, depending on the scenario, 3 to 4 pages long, 1-inch margins, single line of text, single space text. So there's a lot of information, a lot of requirements in the request for proposal. We may ask for things, we'll ask for the normal things. You cannot have a settlement without air, water, food, that kind of stuff.
Right.
It's
Yeah.
either a settlement on a surface, it might be on an asteroid or the moon or Mars, or you actually have some really bizarre scenarios that go to Mercury and Venus. That's a whole other thing. We have orbital settlements. We have settlements in Aldrin cycler orbits between Earth and Mars for transportation purposes. But we'll throw in every one of them, we'll throw in some little kickers. So there might be a settlement on the moon that requires an amusement park. What would you do for entertainment on the moon?
Right.
Well, that's a requirement for structural engineering. Where do you put that? Automation engineering, you probably need some automation. You need some safety and human engineering. And then the thing needs power. So it involves all of the departments. So there's an example of one requirement that affects a lot of different things. And we'll throw that in for some scenarios and not for others. So the kids don't know until they arrive.
And so then how much time do they have to actually put together their proposal?
In a standard semifinal, they'll get that RFP about 10:30 Saturday morning. And by 7:30 Sunday morning, they have to have the design done, the briefing charts prepared, and ready to present to the judges. So if they don't eat and don't sleep, they've got 21 hours.
Right.
And yet a lot of them don't sleep.
Right. No, sleep is optional.
And a lot of our volunteers don't sleep either.
Right. And so then, and for the number of years that this has been happening, I'm hoping that you've been just genuinely amazed at what the ingenuity and some of the ideas that have come out of this competition.
Well, less so than you would think. They are struggling so much just to meet the requirements.
Right.
I go to a lot of conferences, and I know the people who are, especially through National Space Society, and the design competition is considered a project of National Space Society. But through NSS, through some of our conferences and AIAA and other conferences, I'm seeing a lot of the ideas that are coming out already. So we literally feed those ideas to the kids. There are a few really innovative ideas that the kids have come up with. You're probably familiar with mass drivers from the O'Neill days. A kid came up with the idea that you can use mass drivers, not just, especially with modern technology, not just for flinging stuff off the moon, but also we have the avionics now where we can direct something onto the track of a mass driver and slow it down.
Right.
That idea came from a kid. I didn't come up with that one. It's like, well, yeah, that's brilliant.
Right. Just run it in reverse.
Exactly.
Yeah.
Correct.
Yeah. It's like the regenerative braking on an electric car.
Exactly. Yes. Yep.
And so that might be and so like as a source of power, like as electricity. Oh, that's really smart.
Of course it's smart.
Yeah,
yes.
It's such a great idea.
But we don't get many of those. Mostly we are feeding them ideas. So we'll teach them about space elevators. And I know the people like Pete Swan who works on space elevator concepts. So we're delivering a lot of ideas to them, and then they need to turn those ideas into a design that's functional.
One of the big arguments that we get in this world now, people who are space nerds, is, planets versus space itself. And I don't know if you can see behind me, I have a poster that says gravity wells are for suckers. So, once you've left a gravity well, like, why would you go back into another one? Are you crazy? They're for suckers. But still, do you think that, based on the logistics that has happened so far, do you feel like it's going to be that more people are going to live on planets and the moons and things like that, or more people are going to be out in space itself?
That's one of those. Oh, I'm sorry. That's one of those great questions. Now there are going to be at least habitats on the moon and other material sources, especially the moon. I'm excited about the backside of the moon, the lunar highlands. The front side of the moon is mostly basalt. We know what that is. The backside of the moon is virgin territory that's been pummeled by everything the universe can throw at it. And there's probably some bizarre chemistry back there. There may be some products that we can sell back on Earth and justify the transportation costs. The moon is a great source for, and I know people are working on this for real, air and water and a lot of the commodities. And literally in the National Space Society, we're seeing an expectation that commodities will be provided from the moon. So you'll need people on the moon providing those commodities. In the design competition scenarios, we we project, or we tell the students, that the really big settlements, the commercial banking center, the manufacturing facility, those will be orbital. We, in the competition, we define L5 orbit as kind of the commercial sector, and L4 is the Rust Belt of space.
Mm-hmm.
So put all those dirty manufacturing facilities and refineries in L4.
So why the difference between L4 and L5? What's the preference one way or the other, or is it just a way to sort it?
It just kind of developed over time. The idea is sometimes we have subtle little reasons for doing things. And one of the reasons for doing that is we have zoning laws in a lot of cities in the United States. Now, I live in a little town called Nassau Bay that's right next to Houston. Houston has no zoning laws, and it's a mess. So you figure it's when there's a lot of industrialization, those refineries, those manufacturing facilities might have some escapes and some debris. They could get messy, they could get dirty. So you really don't want people living there in their retirement communities and their universities. That's the theory anyway. Is that how it will develop? I have no idea. But partly we're trying to show the kids that there is a reason for having some organization in what you do in space.
Right. It's got to be tough, though, with the time that you spent working on spaceflight, and then how your imagination gets to soar when you look at these settlement ideas, and then you match it to sort of where we currently are, and it's been 50 years since the Apollo landings and so on. How do you feel about all of the stuff that you see today with like reusable rockets from SpaceX and some of the new interesting launchers and so on?
It's like that all should have happened 30 years ago.
Yeah.
I mean, really, I'm right here. I can walk to Johnson Space Center from here. So there were a lot of 50th anniversary of Apollo celebrations. And I actually hosted one at my house, and I went to one other, but I was bummed out that whole 2 weeks because it's like, we should be doing this on the moon. Yeah. Why are we stuck here? We went to the moon and we quit going. That's just dumb.
Yeah. Well, I mean, space is hard. You should know.
Yeah.
And also space is an expense. Like it's going to take a long time before there's any business model that makes any kind of sense. And so it's just going to be this place in the sky where we dump money, right? Until somehow somebody figures it out. But it could take a long time. What kind of infrastructure would you imagine sort of starting to come together that would let us know that we are turning a corner to creating a truly space sort of based civilization?
So, of course, I've got my finger on the pulse of this, and I've been going to the conferences. I'd say about 2.5, 3 years ago, we started seeing some serious interest in on-orbit repair of satellites. On-orbit refueling, on-orbit repair. And honestly, that looks like it'll be kind of a trigger for starting economic activity with people in space. I honestly think that, and I know folks who are looking at this, I honestly think that having access to lunar resources and starting to make commodities from lunar resources is going to open that door.
Yeah, that was a big part of O'Neill's plan. Like the whole O'Neill cylinders really relied on them digging up all that regolith and encasing their settlements inside them.
However, one of the things that really needs to be resolved, and the space lawyers have been looking at this for 35 years or 40 that I know of, is, where it's coming, property rights. If somebody establishes a lunar facility for making air, water, metal, whatever it is, and they don't know that it's their facility as long as they occupy it, if they don't know that they own that, we aren't going anywhere. If the Chinese can just come in, oh, I'm sorry, that's my phone. If the Chinese, the landline, I was going to hang that up and I goofed. But if the Chinese can just march on in and take over something by force, we're hosed.
Yeah.
I do apologize.
Yeah, no, I know, like the Outer Space Treaty, sort of at this point right now, the Outer Space Treaty defines that it's, you can't own anything, right? Yeah. And so everyone, if you make a space station, then anyone can come and use it. And if you find a place of with a lithium reserve, anyone can come and dig into your lithium reserve and mine it themselves. And so obviously here on planet Earth, property rights and ownership of mineral claims and things like that is really the economic engine. And so you can imagine, but I mean, it's sort of like it's so pie in the sky right now. I can imagine at a certain point when it gets real, then lawyers will buckle down and sort this out.
I hope so. So part of it we're seeing also is there's a difference in the European view versus the American view. The American view is based on the homestead laws of the American West. There was a guy, he's now passed away, a guy named Klaus Heiss that I knew through American Institute of Aeronautics and Astronautics, who proposed how property rights could work. We actually incorporate this into the design competition as well. And he suggested if you occupy and work an asteroid that's up to 10 miles in diameter, or a patch of ground that's 10 miles by 10 miles, if you are actively working it like a mining claim in the American West, then it's yours as long as you work it. You abandon it, and if you're not there for 2 years, then it's not yours any longer. And that actually, according to Klaus, was based on the original code of laws by a Babylonian king, Hammurabi. You can look him up.
Wow. He'd be proud to know.
Yeah, he would. And I've actually been accused of being American-centric by suggesting that the property rights of American homesteading law would be useful in space. On the other hand, the Europeans haven't had the experience of homesteading or anything like that for a few thousand years,
right? Because
all of Europe has been owned.
Right.
We Americans have had that experience. The Australians as well. I'm not exactly sure how their laws work. So it's something that needs to be resolved, and that will be a very important event.
So I don't know whether you already answered the next question that I had for you, but which is, like, what do you think is going to be the toughest nut to crack of this?
Oh, that's an easy one. Lunar dust.
Really?
Really. Oh, it's awful stuff.
Yeah.
So it really let's say I only really became aware of how incredibly nasty that stuff is maybe 10 years ago.
Mm-hmm.
And what started coming out is the Apollo spacesuits were trashed. The longest any of them was out on the surface was maybe 24 hours. They came back with abrasions and joints that were frozen and joints that were leaking. It just a mess. And people designed them as best they could for what they thought was coming.
Right.
But the lunar dust has not been blown around. It's not rounded. It's like shards of glass.
Yeah.
And it gets into everything. You can't brush it off. Actually, airlock design is one of the things we challenge the kids with, and we're hoping somebody will come up with a design. But it's a horrible problem, and it's one of those things that until we actually have people living on the moon and facing this problem every day, until we have that, we're not going to solve it. People just literally be there to fix it. If lunar dust wrecks your airlocks in 3 days, it's going to be hard to survive.
And not to mention it getting into your lungs and giving everybody all kinds of respiratory illnesses. Like we've done a few articles on this, and it really looks like a nightmare. The astronauts were suffering from it on their way home, and that's interesting. I've heard recommendations like, maybe we're just going to have to sweep. Like, we're going to have to maintain a clean area that doesn't have a lot of dust, and you pave it to try and minimize that dust. And it could very well be that it's a showstopper. It's so nasty that it causes so much damage to everything that you try to do there. Every piece of machinery, every moving part just gets torn up by the scrapes and scratches from the stuff. Yeah, that's really interesting. I'm going to do more digging into it. I've already sort of been freaked out by it, but I clearly need to if this is the thing that worries you the most, then clearly I need to go deeper.
That's my big thing. This sounds unrelated, but I do raft trips down Grand Canyon. So we camp on Colorado River silt, and that is much coarser than lunar dust and much less abrasive.
Yeah.
And by the end of a week, it is in everything.
Yes.
It is in your food. It's in your clothes. It's in absolutely everything. You can't get rid of it. And that's mild compared to lunar dust.
Oh, terrific. Well, Anita, we could have this conversation all day, but I know I've got to let you go. But where can people find out more, and how can people join the competition for upcoming years?
We have a website, pretty easy. I'll say it and then I'll spell it, www.spaceset.org. www and .org are really easy to spell, but SpaceSet is it's a truncation of space settlement. So all one word, SPACESET. There's a registration page there, so people can sign up as teams or individuals. And that kind of directs people to the right continent. And from there, we'll get you in touch with whoever you need to get in touch with to get involved with semifinals or qualifying competition. In the US, we have qualifying going on right now. So school teams can sign up for qualifying, and we will send them an RFP and some background information, and away they go. And those proposals, it's a 40-page written proposal with a design that's due in April.
Wonderful.
There are actually some schools that incorporate our qualifying competition into their curriculum, their high school curriculum.
Oh, that sounds great. Man, I should have done this when I was younger.
A lot of our volunteers say that.
Yeah, I know. That sounds awesome. All right. Well, again, thank you so much for taking the time to chat with us today. It's really inspiring. I can't wait for us to find out how bad the Mars and moon dust is.
Oh, yeah.
All right.
Just so we don't kill anybody on the way. Thank you so much.
All right.
It's a lot of fun.
Take care.
Appreciate it.
Bye. All right, let's move on to the news portion of our show. And I see that Dr. Pamela Gay just showed up. Pamela, you get to go. You get to go first. Oh, you're muted again.
Sorry. Hello, everyone. I am clearly not to be trusted with the mute button.
No.
This has been an incredible news week for me personally, because the Osiris-Rex mission has announced the sample site and secondary sample site for their plunge down to the surface of Bennu. The primary site that they're hoping to go to is Nightingale. It is in the northern hemisphere. It's a bit more difficult to get to, but this crater within a crater is one that appears to have a high diversity of materials inside of it, and it appears to be nice and small and granular and easy to get with our angry vacuum cleaner, with which the surface of Bennu shall be attacked.
So I'm gonna bring up the actual landing site here so people can see. I'll share it at you just so you can just talk people through it, because this is crazy. This was the best they could do.
Yes. So
that is tight.
Here is where I need to remind everyone that, first of all, this is not a rock anyone requested. Bennu is a rubble pile asteroid. And what we have learned is when you say rubble pile asteroid, it does not actually mean that you have an asteroid that's been broken up into like 10 or 12 pieces. It means that you have rocks on rocks with boulders on boulders and rocks on the boulders.
Right. And so you're looking at this, and it really is just this like tiny little spot that's got like a little bit of sand surrounded by gigantic spacecraft killing boulders.
And all four of the potential sample sites were actually craters. And this is because craters are the places where a different, bigger space rock came in and crunched things up and down a little to make a slightly bigger, clear-ish space. And this is why there's a secondary site as well, because the spacecraft Osiris-Rex has onboard hazard mitigation software that is fully capable of going, oh, expletive, we're about to break everything. Aborting landing, or it's not a landing, aborting tagging the asteroid and grabbing a sample. And there's enough fuel on board and enough nitrogen gas, which is what they use to blast the surface to stir up stuff into the sampling device, that they can do multiple attempts. And the secondary site, Osprey, is one that's much easier to get to. It's along the equator. It does have a ginormous boulder right on the edge of it, which is a bit intimidating, I will say. But if they do have to go to Osprey, this is a site that has been shown to have carbon minerals in it. And we are, after all, hoping that we will find organics. Now,
is that why, like, it looks like this sort of dark blotch on the surface
yes.
of the asteroid, and so that's how they know it has carbon in it?
Well, they actually did reflection spectra. So you look at sunlight hitting the rocks, and then you see what colors of light reflect back. And different minerals have different reflection spectra. So we can differentiate between different kinds of minerals based on how they reflect sunlight. So we have two possible regions, one of them a little sketchier than the other, but good science should hopefully be happening. Now, we're going to have to wait a bit. There is going to be a rehearsal around the New Year's this year, but the actual sampling won't be happening until the end of next year.
So can you, I mean, a lot of the people that are watching this show were some of the volunteers that helped find this
Yes.
landing spot. So how much work went into that? How many rocks were categorized? Do you have some sort of sense of the enormous scale that it took to be able to find these landing spots?
I do, and I'm going to be working on data visualizations for this tomorrow. And we are currently awaiting approvals to announce the names of the people who marked these sites. We had over 3,500 people each mark at least one image each. And images took anywhere from 15 to 45 minutes to mark.
Right.
So this isn't like a lot of the citizen science projects that are out there where you're just like, click, okay, I'm done with this image, click, done with this image. No, this was painstaking, agony-inducing work that these people did. We had 7 individuals who marked over 1,000 images each. They actually did secondary marking of the 4 sample sites, looking at the high resolution images. Now, the reason these 7 were selected is they had so many images that it was really easy to run the stats and show that their work was pretty much on par with what we were getting from the scientists. So our citizen scientists rocked out the rocks. Altogether, these 3,500 people marked over 14 million things.
So we know of 14 million things on Bennu.
It's more like we know of 1 million things because each image was viewed by 15 people.
So things were mapped multiple times.
Right.
Okay.
But this is a small asteroid. This would like fit on a big city block. It's 500 meters across. I have the capacity to run the diameter of this asteroid. And so finding 1 million of anything on an object this small is kind of impressive.
Yeah, it's like the best mapped place in the solar system.
Or most completely.
Yeah.
And
yeah, we know more about this rock than we know about the Earth in totality when you think about the oceans and such. Yeah.
Doing the statistics on this is something that is going to take a long time, and I'm looking forward to getting the chance to do. And it's really kind of an amazing discovery process that we've gotten to go through. And it was the citizen scientists, it was science teams around the world using a variety of different detectors, trying to find, well, where do we have the most interesting spectra? Where do we have the most interesting science? And we did it, folks. We did the thing.
Yeah. And it's funny, we watched that rocket launch.
We did. We were there in person.
3 years ago. Yeah, in person to watch this thing launch. And then, 3,500 of our closest friends mapped this thing to within literally an inch of its life. And now the spacecraft's job is to safely collect a sample and bring it back home to Earth and to bring back a significant chunk of asteroid material. I can't wait. This is so great.
I can't wait either.
Yeah.
It's really kind of amazing.
Yeah. All right. The other Pam Hoffman, tell us about some upcoming eclipses.
Hi there. Thanks so much. Fraser. For me, I like to talk about stuff you can do from where you are. And we talked about the investment last time, very big news. But what I want to talk about today is this annular solar eclipse. Now, an annular eclipse means the moon is too far away to completely cover the sun. In this case, you need to filter the whole entire time. You cannot leave.
Right. Don't look at it with your eyes.
Right. You want to protect yourself. And so this will be a ring of sunlight that appears around the basically new moon. It'll appear dark. And one day they're all going to be annular eclipses. The moon moves away from the earth about 1 centimeter a year. For viewers in the United States, this is going to be a very nice Christmas present. It starts in the evening on December the 25th. And basically, it's going to be something you can see by webcam in the United States. For our area, I'm in Southern California, about 6:30 p.m. on Christmas Day, we can start to see things by webcam, including the partials, places they're only going to see a partial eclipse for this. And the maximum is about 9:17 here. That's midnight Eastern. So we're heading into December the 26th. It ends December 26th, 12:05 a.m. here, 3:05 a.m. in the Eastern time zone. And that's the end of the partials. So there's like partial, full, maximum, partial. And so what it means, though, is that this is happening in the opposite part of the world. The central path goes through Saudi Arabia, southern India, Sumatra, Borneo, the Philippines, Guam, northern Sri Lanka, part of the Indian Ocean, Indonesia, and part of the Pacific Ocean. The partial eclipse aspect of it will be in parts of Eastern Europe, most of Asia, North and West Australia, and Eastern Africa. There's a really great animation on timeanddate.com. I just did a search for December 2019 eclipse, and I found that and more. The live coverage is available. They've already started to count down. It's a YouTube channel, and I just put in watch December 2019 eclipse live. And, generally there's like 4 to 6 eclipses a year. Next year, there are 6. 2 are going to be solar type eclipses, and 4 are going to be moon type eclipses. And we've got total, partial, annular, penumbral. People chase these things all around the world. It's amazing.
Did you catch the eclipse that happened back in 2017?
Oh yeah. We here in Southern California just had a partial eclipse for that, but we went out and looked. It was great.
Oh, you didn't drive to the totality line in somewhere in Oregon?
No, I didn't go anywhere else. And I set up around home so that my neighbors can come and look too. So, and just by the way, the next major one here in the United States will be April of 2024. So
right.
No time to waste, right?
Yeah, no, I'm already planning. I think I'll be in Texas for this one.
Oh, very cool.
Yeah, so it's gonna pass like right through Austin. I've got a bunch of friends there, so I think I'm gonna go for Texas.
You get the filters and stuff before that. You're not gonna risk, finding shady deals.
No. We had a good line on glasses last time for the 2017 eclipse. So I'm pretty excited though, because we and Pamela was with me, the other Pamela. We were there for the 2017 one, and we were at the place of maximum duration. Nice. But big cloud showed up right in the middle, and we didn't get a chance to really see all of totality. Just like I got to see like the last few seconds. And Pamela, you didn't see anything, right? So that's
I saw nothing.
Yeah, that's 2 solar eclipses for you down. So we've got to, we'll nail the 2024 one. There's also a meteor shower coming up, right?
Yeah, that's going to be the 21st. It's fairly minor. and they're not going to have too many, per minute kind of, viewings. Let's see, I got some notes here. That was the eclipse was the main thing. Yeah, this is the Ursid's meteor shower. And shoot, I had something about how many, it's only like 15 to 20 an hour. I mean, a minute is pretty hard. When they say 60 an hour, that's pretty hard to wait.
Yeah.
Especially now with the, computers go super fast, and we've got mobile devices we carry everywhere. But yeah, this will be just 15 to 20 an hour. So kind of minor, but again, it'll be worldwide at least. And you want to look like after midnight, after the Earth has, turned into the debris field. I think that's from the Temple
awesome
comet. Yeah.
And like my favorite is the Perseids, mostly because it's warm in the northern hemisphere for the Perseids. They're not the best one, but the big one, like I saw the Leonids back in, I think it was 2001, and it was a meteor, full-on meteor storm, and I was in the middle of Vancouver, like the city of Vancouver, horrible light pollution, and I saw just tons and tons of really bright meteors. Yeah. So I mean, if you can get a chance to see a meteor storm, so every now and then astronomers will say this could be a meteor storm, and whenever they say that, like I always recommend, like go out and check it out, because when it is a meteor storm, it's unbelievable.
Yeah, there was one recently. We did try and get out in the field, but we couldn't see anything.
Yeah, it ended up being, and that was one of those situations where it turned out to be a false alarm. But you never know, right? Sometimes it is. Right. And the one that one, the 2001 meteor storm was absolutely, as bright. Was it 90? I'm sure it was 2003, 2001. Anyway, really bright, really great. Definitely cool. Check it out. All right. Last but not least. Dr. Brian Koberlein, what do you got for us?
So I have an interesting thing on Aurora on Mars. And this kind of has a connection to science fiction in the TV series Expanse. There's a little moment where they talk about the Aurora on Mars, that it's odd to see them. And it would be, because when we think of Aurora here on Earth, they are colorful, they can fill the night sky, and that's because we have a strong magnetic field. Charged particles from the solar wind go spiraling along the magnetic field and then hit our nice thick atmosphere, and so we get all these bright colors. And Mars right now doesn't have that. There aren't visible aurora on Mars, but there are ultraviolet aurora, and they're called proton aurora. And basically what it happens is when the solar wind strikes Mars, there is hydrogen in the upper atmosphere of Mars. The solar protons smack into them. When the electrons recombine, they create ultraviolet light. And this has been picked up by the MAVEN satellite that has an ultraviolet camera on it. And so they've been studying it for the past several years, and they've noticed that the aurora on Mars is seasonal. So what happens is it's most intense when it's summer in the southern hemisphere of Mars, which is also when Mars is closest to the sun. So like Earth, Mars's orbit is a little bit elliptical, and so it varies a little bit in distance. So when it's closest, when the southern part of Mars is exposed to the sun, that's also when it's the warmest. So what they found was that these aurora were brightest during the period in which Mars is the warmest and when its atmosphere is the most active. And it occurs when there's hydrogen in the upper atmosphere. So you're seeing this seasonal level of how much hydrogen there is in the upper atmosphere, and that's fed by water vapor.
Right, and this is the stuff that's being blasted away from Mars by the sun's solar wind, right? So you're sort of watching Mars die. Yes,
that's kind of the interesting thing, is that this aurora is showing this seasonal loss of water vapor from Mars, which is one of the mechanisms for how you would have a drier Mars instead of a wet Mars, because Mars used to be wet in its early history.
So do we have like that kind of a proton auroras here on Earth as well?
We do, but it's not the main thing that people talk about.
Right. So it's
because there is hydrogen in our upper atmosphere.
yeah,
because
that's what I was
it comes
thinking.
from
So
water
you're
vapor.
going to have water
And
vapor as well.
So it is there, but it's not the dominant aurora that we talk about.
Right.
We also have a strong magnetic field. So on Mars, there really isn't a whole lot of magnetic field. So this aurora actually happens on the sun side of Mars. It's not in the dark skies of Mars, because what's happening is the solar wind is just literally slamming in to the solar side of Mars.
We know that Mars has almost no magnetic field, and definitely no global magnetosphere today. Do we think that it had one in the past?
That I'm not sure about. I don't know how much evidence there is for the history of the magnetic field of Mars. There's a lot of evidence for the history of a wet Mars, both geologically and just in terms of its own evolution. So we know it was very wet. We know it had oceans and rivers, but I'm not sure about how much of a magnetic field it had.
Yeah. And I wonder, I sort of think about this, like on the one hand, this is a way to chart the water loss, to sort of really track. And I wonder if it could even be used to help figure out some sources of the water that are beyond. Like we know there's big polar ice caps, and so during the summertime, maybe some of that is sublimating off of the ice caps and directly into the atmosphere. But maybe you could get to a point where you're actually watching these auroras form because there's water vapor that's emanating from various sources of water that you didn't necessarily know. So I wonder sort of how far along that process they are.
Right. I mean, they've had a few seasons now. So I think it's like 5 or 6 years is how long they've had, the observatory of this. So it's as you get more satellites, as you get more observatories, as you get more ground-based stuff, we're going to start seeing the dynamic picture of Mars both now and what it was in the past.
I don't know if you saw, there was a piece of research that just came out. We actually had this on Universe Today yesterday, I think, or 2 days ago, that it looks like there's a lot more water on Mars very close to the surface, like frozen, but frozen into the regolith, and so easy to get, you could dig it out with a shovel.
Yes. Yeah, it's the visual of that. Just pull out your little pitchfork.
Yeah, dig and pull some water, and then use that.
Get some water.
Yeah, yep. And then use that to make fuel and air and plastic and whatever you need. So it's a pretty great idea. So it could very well be that in fact it makes a lot more sense for future visitors to Mars to head closer to the poles than to be down near the equator where it's warm but dry.
Right. And that's kind of a question that I think that's still being answered, is how much of the water of early Mars is now frozen into the crust, into below the surface, and how much of it actually was just lost.
Right.
And that's, in terms of a colonization aspect, that's a big question, because if there are large sources of water you can tap into, that makes colonization much, much easier.
Mm-hmm. And even down the road, if you can warm it up any amount, then you can start to release some of that water and have it make its way to some of the lowlands and build up the density of the atmosphere, and that'd be great.
Exactly, and that's what they're trying to do in the Expanse.
Yeah, exactly.
And the artificial magnetic field, which I think is neat. Every now and then you get they've got these satellites that create the artificial magnetic field for Mars. Every now and then in the animation, you'll catch a glimpse of it.
Oh, that's so cool. It's amazing how much they've thought of everything. Again, if you haven't been watching The Expanse, I just raved about it actually on one of my question shows on my YouTube channel. We talked about it on Monday. It's such a good show. I'm so glad. All right. Well, we've reached the end of our time. Brian, you're on my screen, so tell us what you're working on and where people can find out more.
Let's see. I'm going to be putting up an article tomorrow on oxygen and the history of oxygen on exoplanets. I think there's already a Universe Today article that beat me to it. So
you're going to put it somewhere else.
So this will be probably somewhere else.
Okay.
But yeah, you can find me. Sometimes I write on Forbes, and I write on my own website, which is briancarberline.com. That's kind of where you can find most of my stuff, and then on Twitter from time to time.
Excellent. Pamela, what are you working on, and where can people find out more? I guess you've sort of told us what you're working on.
Well, I have many things going
That's
on.
true.
You know this about me. So this weekend we are going to be doing a 40-hour straight hangout-a-thon once again. And in fact, you know this because both you and Brian are going to be guests at various hours during the event. So if you've always thought science needed more funding and you're willing to give a few dollars to that idea, show up, support us. You can learn more at hangoutathon.org or just tune in anytime this weekend at twitch.tv/CosmoQuestX. 40 hours of guests, art, science, space-related cooking, and raising funds for what I hope you feel is a good cause.
Awesome. And Pam, what
Boy,
are you
that
working
sounds
on?
fabulous. Yeah. Second book
Yep.
after this one's still available on Amazon. I'm teaching a class that's very local here in Thousand Oaks, but we've really tuned into what people want and had a really lot of fun this last time. Just finished last night. I've got several meetups across the country. Really want to bring this to people. What can you do? What can you see? Where can you go? What kinds of things are available online? You know, all about action for regular folks. I think they get left behind a lot of times, and really want to help, you know, bring them into this. It's going to be a space age very soon, I think.
I think we're already
about
there.
time.
We're already there,
Yeah.
and
Yeah.
exactly about time.
The vanguard of it, yeah.
Yeah.
Thanks.
So we released a video this week about the predictions of 100 million exoplanets by 2050. So definitely check that out on my YouTube channel. And we've been posting a ton of really cool news onto Universe Today. So as always, check out Universe Today. I'm going to put everyone back on my screen. There we all are. Thank you so much, everybody, for watching us today. What an amazing guest. That was really exciting. It's such a treat to talk with Anita. We need to definitely get her back on the show sometime. Thanks to Nancy, I believe, for organizing this one. And thanks to all the moderators, everyone who is simulcasting this both on YouTube and on Twitch. I couldn't handle that additional engineering challenge, broadcasting challenge. So thank you so much for doing that, everybody. And thanks to all my co-hosts this week. Appreciate you joining me, and we will see all of you. I don't know when next. I think a week from today is like Christmas. I don't think we're doing an episode on Christmas. So Nancy will tell us when. Let's see. The next Astronomy Cast is on Sunday. We're going to be doing that on Sunday at 11 a.m. Pacific. And I don't know what the state of the Weekly Space Hangout is. Oh, there we go. In 3 weeks. So no episode for the next 2 weeks. And then we'll be back. Possibly from Honolulu. Because we're all going to be at the American Astronomical Society meeting in Honolulu. So, all right, everybody. We'll see you all next year. Next decade. Thanks, everyone.
Happy holidays. Good night.
Bye.